All right, welcome to the second Surfer webinar on scripting for beginners. My name is Katie Yoder. I'm a member of the technical support team at Golden Software, and I'm here today to go over some additional information about Surfer's scripter application. In my last webinar, we reviewed the available resources and the elements of a basic script to get you started. Today, we'll dive a little deeper into automation and review how to automate repetitive map making workflows. Specifically, we'll be reviewing how to combine multiple script examples, how to debug or troubleshoot automation errors, and how to prompt a user for information in a script. After the discussion of each topic, I will have time for 1 or 2 questions. You can send your questions to the webinar host via the questions box on the webinar control panel. Type in your question and it will be sent to the webinar host, who will forward it to me. Please send in your questions, but if I don't get to them, I will follow up with an email after the webinar is completed. This webinar will also be recorded, so after the webinar is finished, if you missed anything or want to rewatch something, the video will be available to view on our support site at support.goldensoftware.com. All right, let's get started. The first thing we'll be reviewing today is how to combine multiple script examples into a single script. As we discussed in the last webinar, there are several locations where sample scripts can be found. These include the samples directory, the Golden Software Support Portal, and the Surfer Help. One of the simplest ways to create a new script is to combine multiple script snippets from samples in these locations. To illustrate how this can be done, let's create a small script that will grid a data file, create a contour map with custom settings, and export to Google Earth KMZ. The first thing I recommend doing when creating a new script is determining what steps are needed to create the desired map, and then looking for sample scripts that could be helpful. In this case, sample scripts related to gridding, contour maps, and export will be helpful, so I'll look for those first. To do this, I'll open Scripter, click File Open, and navigate to the Samples directory. The default Samples directory is C, Program Files, Golden Software, Surfer 14, Samples, and Scripts. The names of these scripts give a general idea of what each script does. So the Axes sample script will edit different axis properties, and the base map script will edit a number of base map properties. For our desired workflow, let's take a look at contourmap.bas. We can browse through the green comments to see what the script does, as shown here. This script opens Surfer, grids a defined data file, assigns no data outside a polygon, creates a contour map, and then adjusts several of the contour map properties. Since this script creates a grid file and a contour map, we only need to look for an export script at this point. If we click File Open and navigate to the Samples directory again, we'll see there isn't a script here that really deals with export. So we're going to need to look somewhere else. To do this, I'm going to click Help, Surfer Automation Help, which will open Surfer's Help to the Surfer Automation section. In the Help, we can browse topics in the Contents tab here, or click Search to search for a specific topic. Let's click Search and then enter Export Automation, and then I'll press Enter to submit the search. I added automation to the search because I didn't want information about exporting through the user interface. I only wanted information about exporting via automation. And here we can see the first result is probably what we're looking for. If we double-click Export Automation, in the search results, you'll see a lot of information about this command in the right pane. Pay attention to the summary at the top of the automation help pages because it provides important information about related commands and properties. Here we can see that a new export command was added that has additional functionality, so we should use that one. I'll click Export to open that page. And now that we have examples open for each of the workflows we need, we can begin piecing together our script. Let's first go through the contour map.bas sample script and copy what we need. So I'll minimize script or the help here. If you find a script that performs a lot of the workflows you need, another option would be to edit the existing script. But for the purposes of this webinar, we'll start from scratch. So first and foremost, we need to open Surfer. Lines 1 to 11 in the contour map sample script do this, so I'll copy these into my empty script. I don't need two sub-main commands because these are what begin a process, so I'll delete one of those. The debug clear command is used to remove any previous debug results. While we don't have any of those at the moment, I'm going to leave it because we'll discuss these types of commands in the next section. Next, we need to grid our data file, so we'll click back to the contour map sample script to see what was done there. In this script, you can see each of the input and output files defined in lines 13 to 18. I like doing this as well because it makes it much easier to make changes to the script down the road. However, we won't need all of these, so I'll only copy lines 13 to 15, which define the data file and the output grid file. The file paths here are defining files found in the samples directory. I'll leave the data file, but I'm going to change the name of the outgrid variable to demogrid2.grd. We still need to grid the data, so I'll click back to the contour map sample script and then copy lines 20 to 22, which grids the data. Now, if we take a look at these lines, you can see the algorithm is defined as SRF min curvature or minimum curvature, and it also defines 200 rows and 200 columns, as well as a fault file. We aren't going to use a fault file, so I'm going to delete this portion of the script. I also want to use the gridding method, so I'm going to change the algorithm to SRF krigging. The rest of this looks good, so I'll leave it alone. Now that we have a grid file, we can create a contour map. In the contour map sample script, this begins on line 27. Here you can see that they first declare the map frame object and then set it to be a plot with a contour layer. We can copy lines 24 to 28 over to our script and update the grid file name to be outgrid. Now that we have a contour map, we can apply some custom properties. So we'll click back to this sample script and see what they did there. I don't want to apply all of these properties to our contour map, but I do want to define a custom color map and fill the contours. Lines 62 to 66 do this in the sample script. So I will copy these to my new script. However, I'm not a big fan of the rainbow color map, so I'm going to change this to rainbow 5, which has more terrain type colors in it. Finally, we're ready to export the contour map to Google Earth KMZ format. So let's open the help back up and take a closer look at the Export To page. The first section of the help page provides a small summary of what the command does. This is followed by a syntax section, which provides all of the available parameters, the remarks section, which provides some additional information about how certain parameters are handled, and below that are an example or two of how the command can be used. Let's copy example 1 into our script and then adjust it based on what we're trying to do. This example exports to TIFF format with a specified resolution and aspect ratio. Since we're exporting to KMZ, the options we're going to use will be slightly different. This command also requires a file name which we did not define earlier, so we'll need to enter the full path and name here or define it in our input and output files as we did earlier. I do prefer to have one place where I may need to make changes to file names and locations, so I'm going to add the export file name and path in the same place as we added the input and output files. To do so, we'll scroll up a little bit and add a new line after outgrid, and then we'll enter KMZ out equals surfer app.path plus samples demo grid 2.kmz. We can edit the now we can edit the export command file name to be KMZ out. And that's the first parameter here in the export to line. Next, we need to edit the options, so we'll need to take another look at the help page. We know we want to export to KMZ, so we'll click the Export Filter ID and Options in the Filter ID row of the syntax table here. This page gives a list of all of the available export filter IDs and their associated options. So if we scroll down, we can see that KMZ is the filter ID that needs to be used in our export to command. And then we can click on the Google Earth KMZ export options link to see what options are available. This table of options can look fairly overwhelming, but remember that we only need to define an option if the default isn't going to work. In this case, I think the defaults will work just fine, so we can just remove that portion of the code. So if we minimize this and go back to our script, we'll delete the options altogether and then change the filter ID to KMZ. Are there any questions so far about combining sample scripts to create your own custom script? In the next section, we'll run the script and use some of the debugging features to address any errors, so I'll wait to answer those questions until a little later. All right, so we do have one question. When I'm defining a data file or output grid, how would I define a location that isn't in the samples directory? So to define a file location other than the samples directory, you can just enter the full file path in quotes rather than using this surfer app path parameter. What this does is calls the location of the surfer executable file, and then we're adding the remainder of the file path. If you wanted to define a location like your documents, you would enter C:users /KD / my documents, or something similar, all in quotes on these lines. All right, so if there are no other questions, we'll move on to the next section, which is debugging a script. When you're new to scripting, errors can get frustrating because it is not always clear what is causing the error that you're getting. You may also sometimes find that a script does not do what you would expect. So the next thing we're going to do is try to run the script we put together and use the debugging features to address any errors. Common debugging workflows and commands include the debug step commands, on-error functions, and debug print commands. Values can also be entered into the watch, immediate, and code windows to see what has been defined. Before we get started with this, let's make sure that the view status bar and view immediate options are checked. Those are in the view menu here. To run the script, we can click Script Run, press F5 on the keyboard, or press the Start Resume button in the icon tray. The script will run until it reaches an error. So we're receiving the error expecting a valid data type, e.g. integer. So let's click OK and take a closer look at our script. The error occurred on line 29, where we're filling the contours, and the error message indicated that the object or data type is not recognized. If you remember from our last webinar, a valid object must be defined before we can apply properties to it. In this case, the last object we defined was the map frame. To get our contour properties to be applied, we need to define the contour layer as an object. So let's take another look at the contour map sample script to see what was done there. Since the last object that we have defined is the map frame, I'm going to scroll up to that section of the sample script. The next thing that is done here is that they adjust the size of the map, which we don't need to do. But after that, you can see that the contour layer object is defined in lines 38 to 40. So let's copy these 3 lines. We'll need to add them before the fill contours. And now we can click Script Run again and see if that resolves the error. So it looks like that did resolve the error we were initially getting, and now we're getting another error that indicates that Scripter is expecting a close parentheses on line 38. So if we click OK, you'll see that the cursor indicates it's expecting a close parentheses before the quote on the KMZ filter ID. This makes me think that the quotes aren't necessary, so I'm just going to remove those and see if that resolves the second error that we were getting. And I'll click Start Resume again. And it looks like the script did run to completion. So if I move this to the side, you can see that a contour map was created using the Rainbow 5 color map. And it was then exported to KMZ. So there are several other debugging options that you may find helpful when working on future scripts. So let's walk through a few of those. The two debugging workflows that I use most often are stepping through a script line by line and using the debug print command. The debug print command is helpful in verifying that any defined variables are called as expected in the script. These are especially helpful when prompting a user for information or extracting file paths and extensions from a full file name and path. We'll go over this a little in the next section, but for the time being, let's add a debug print command into our script so that you can see the results. So we defined our variables at the beginning of the script, so I'll scroll up to that section. And we can add a debug print data file command, which will print the full file path and name of the data file variable. Another option would be to add debug print and then in quotes data file equals what this will do is print the string that we defined in quotes to the immediate window, followed by the data file variable, full file path and name. So let's step through the script to see what exactly these two commands do and how they differ. To step through a script, we can click Debug Step Into. You can also press F8 on your keyboard or click the Step Into icon here. Each time the Step Into command is clicked, the next line of the script is highlighted. This lets you know the next line. So if we keep different lines are highlighted, immediate window, the full file path and name printed here. If we click again, you'll see the string printed first before the full file name and path. I find adding a definition or explanation of what the debug command is doing very helpful, especially when there are multiple debug statements in the script. So I'm going to click Stop and delete the debug command that doesn't have that description. Another debugging option is to use the immediate window. This can be used if you only want to check the value of a variable once rather than each time the script is run, and it's an alternative to the debug print command. To do this, the script has to be paused or in the debug step through commands, and your variable has to have been called already. So we'll click the Step Into command until we get past the variable definitions. And then we can click a question mark followed by data file, and you'll see the full file name and path printed here. Another option is to double click the variable name in the code window and then click the Debug Quick Watch command. This will print the name of the variable followed by the full file path and name. You can also add the variable name to the watch window. Which produces similar results. The watch window is most helpful when your script has loops in it and the variable name changes as the loops are run. Another debugging option is to just tell Surfer to ignore errors and keep running the script. This is not always a great option, but can be helpful in some instances. For example, you have a script that may be run in several different versions of Surfer. While we do our best to ensure scripting commands are forward and backward compatible, there are some cases where this is not possible. new features, for instance. If you want Scripter to ignore a line of code that is not supported and therefore results in an error, an on-error command can be used. On-error commands are most commonly set up as subroutines that only run if called. To add an on-error subroutine to this script, we would first go to the end of the script. Well, first we need to stop. Then we'll scroll to the end and add exit sub. This defines the end of the script proper and the beginning of a subroutine. Next, we'll add error label. This is the name of the subroutine we're creating. Then a debug print command, which prints the error message thrown by Scripter, and an error clear command, which clears any previous errors in case a new error is encountered. Finally, we need to tell Scripter what to do now that the error has been dealt with. So we're going to tell it to move on to the next line of code, and then we're going to exit the subroutine. So now that we have a subroutine, we have to go into our script and add the on-error command that tells Surfer when to run this subroutine. So to do this, we'll scroll up to the very beginning of the script right before Surfer is opened, and we're going to enter on-error. Oops. Go to error label, which is the name of our subroutine. If we want to test this in Scripter using this script, we can change the name of the color map to one that doesn't exist. So I'm going to scroll down to line 35 and change Rainbow 5 to Rainbow 55. And now when we click Script Run, we'll see an error printed here, unknown fill pattern, and the line that it was encountered on. And if we minimize Scripter again, you can see that the rainbow color map was not applied. Instead, the default grayscale is visible. So are there any questions about debugging scripts in Surfer or anything else we've covered thus far? So one of the questions we have is there a particular order you need to write the script in? Generally speaking, we recommend that you write the script in the same order that you would perform operations in the user interface. So before you can create a map, you have to have a grid file. Before you create a grid file, you have to have a data file, that kind of thing. You also want to always have your objects defined before you apply any properties, which we ran into earlier. Are there any other questions? All right. So now that we know how to put a script together from sample scripts and the help, we can troubleshoot debugging tools, and it's time to be run without manually defining. The two most common are get file name and value input box. The get file name command opens the Windows File Explorer dialog, where the user can navigate to and select a data file. The variable value achieved from this process is a full file path and name, similar to the variables we defined manually in our script. The val input box command can be used to get any numeric or string value from the user. For example, when gridding a dataset, you may want the user to define the grid spacing so that the grids can be used later to perform grid operations. This command can be used to prompt the user for the grid spacing value. So let's add each of these to our script. First, rather than defining a specific data file, I want to prompt the user to choose a data file. So I'll change line 16 to read data file equals get file path. And when I enter the open parentheses, you'll see each of the available parameters that are available for the get file path command. The first available parameter is by value default name as string, which is used to define the default file name. I would rather the script not run than run with a default file, so I'll just enter a comma to skip this one. The next parameter is by value default extension as string, which is used to define the file extension that we're interested in. For this script, this could be anything from a DAT to an XLS. So I'll enter CSV, DAT, TXT, XLS, and XLSX in quotes here, and then another comma to move on to the next variable. The fourth variable available is by value default directory as string, which defines the default directory that will open in the Windows Explorer dialog. If this is left blank, Scripter will default to the current directory, which is fine for us. So I'll just enter another comma. If we want to add a default directory, we would enter it much like we did our variable definitions, except the file name would be left off the path. The fifth parameter is by value title as string, which defines the title of the dialog shown to the user. So let's enter select data file for use in gridding and contouring, and another comma. And the final parameter is by value option as string. This parameter allows you to set options such as allowing the user to select an invalid file or a file that does not exist. In most cases, you'll want to enter a 0 or 4 here. Entering 0 only allows the user to select a file that currently exists, and entering 4 does the same, but also changes the current directory to the directory of the chosen file. Let's enter 4 in this script, and then we can close parentheses. Now that we have a user prompt for the data file, we'll want to adjust our outgrid and KMZ out variables so that they're named similarly to the input data file. To do this, we'll need to parse the full file path and data file to only the portions that we need. This can be done using basic string commands from the WinRAP Basic Help in Scripter. We don't have time to go over these in detail today, so I'm just going to copy some commands that I commonly use, and we can review those. The 3 lines I added here define the file directory, the output grid, and the output KMZ file. The in_str_rev searches the defined string or variable defined for the position of the last value defined in quotes. For the file directory command, it is locating the last backslash in the data file name and noting its position in the string. The left command tells Scripter to return a string with only the number of characters defined. So combined, these lines tell Scripter to return everything in the data file path to the left of the backslash and period, respectively. In the case of outgrid and KMZ out, we then add the desired extension back to the returned string. If we want to ensure that these values are returned properly, we can add debug statements below each line. So we can add debug print file directory equals and then the same here. And one more time for the output KMZ file. The input box user prompt that is often used is a bit more straightforward, as it just returns a single value. Let's quickly add one of these to our script to define the number of columns and rows in our grid file. We'll want to do this before the grid file is created, so right underneath the variables we just defined, we can add a new input box command. I'm going to call it grid columns. And I'm going to name the dialog. Enter. So the parameters for the input box are first the prompt or description of the value you're asking for, then the title of the dialog and the default value. We can also define the position where the dialog will appear, but I chose not to do this because it will be displayed in the center of the screen if we leave them off. Now that we have the rows and columns defined as an input or user inputted variable, we'll want to change that in our grid lines of code. So I'll change 200 here to grid calls. And then we're pretty much ready to go. So now let's step through the script so that we can see exactly how each of these additions changed the script. Oops, looks like I forgot a parentheses here. So one more time. So after line 2, you can see that all of the previous debug statements were removed from the immediate pane. If we keep going, we'll get prompted to choose a data file. And I'm going to choose the well locations.dat file in our samples directory. And before we continue, I'm going to adjust the scripter and surfer windows so that you can see exactly what is happening here. Now when we press the step into command or F8, the debug statements will allow us to see how each of the variables that we defined are related to the initial data file that we prompted the user for. Next, we're going to be prompted for the number of data columns, which seems to be hidden here. I apologize. There we go. So in this grid resolution prompt, I'm going to enter 100 for the number of rows and columns and click OK. And at this point, we can keep stepping through the script, or we could also click play to finish everything quickly. I'm going to step through so you can see exactly what's happening. And it looks like we forgot to change our color map name, so the error subroutine is being run as well. And that's the end of the script. So are there any questions about this or any other parts of the webinar that haven't already been answered? One question is, where can I find more information about the parsing commands that were used? The WinWrap Basic Help has has information about each of the available commands that can be used to parse a string value. So to find these, we would click the Help, Basic Language Help, and then we'll click the string link here. And here you can see a list of all of the available parsing commands for strings. And if we were to click left, you can see a description of how this command works. Oh, so another question is, how can I loop through multiple files in a folder to create maps? So there are a few ways to do this, but the most common way would be to use a loop with a for I, or there are a few other looping options. Carrie Dickinson, our Surfer product manager, actually presented a webinar last year that reviews how to add loops to your scripts, and that webinar is available on our website. The title is String and Simple Loops, and I would recommend emailing us if you have any questions about the information. Are there any other questions? All right. So that wraps up our presentation on automating map creation in Scripter and Surfer. If you have any additional questions, once the webinar is concluded, you can call our technical support phone line at 303-279-1021, or email questions to either surfersupport@goldensoftware.com or directly to me at Katie, that's Katie, @goldensoftware.com. Again, a recording of this webinar will be posted shortly on our website at support.goldensoftware.com. Thank you for your time, everyone. I hope you have a great day.